In coordinate geometry, understanding properties of lines and angles formed by intersecting lines is something that is imperative for you to know. In this video, I want to go over some basic definitions, as well as show you some examples. We'll start with vertical angles. Vertical angles, despite what they sound like, are not straight up and down. What they are each of the pairs of angles on opposite sides of intersecting lines. And vertical angles are always equal. So if we look at the figure in the bottom left, we see angle XBC is labeled as 30 degrees. The vertical angle to that is angle ABY. So we know that angle ABY is also 30 degrees. Supplementary angles are two angles that add up to 180 degrees. Because points A, B, and C all fall on the same line, and because angle XBC is 30 degrees, we know that angle ABX has to be 150 degrees. That's because a line is 180 degrees. So we can say that angle ABX and angle XBC are supplementary. The other thing we can fill in is angle YBC, which must also be 150 degrees because it is a vertical angle to angle ABX. Complementary angles are two angles that add up to 90 degrees. Oftentimes your knowledge of complementary angles is tested in situations where you have rectangles or squares, and the corner of one of the rectangles or squares has a line drawn through it that forms two angles. When two lines are crossed by another line, called a transversal, the angles in the same relative positions of the intersection are called corresponding angles. When the two lines are parallel, corresponding angles are equal. If we look at the middle figure, we can see angle BEF and angle XBC are corresponding angles. And because line AC and line DF are parallel, this must mean that angle XBC is 60 degrees. When two lines are crossed by a transversal, the angles on the inner side of each of those lines, but on opposite sides of the transversal, are called alternate interior angles. When the two lines are parallel, alternate interior angles are equal. So again, looking at the middle figure, we have angle BEF and angle ABE are alternate interior angles. Because we know the measure of BEF, we also know the measure of ABE, which is 60 degrees. Likewise, we could have figured out that ABE was 60 degrees because it is a vertical angle with XBC. When two lines are crossed by a transversal, the angles on the outer side of each of those lines, but on opposite sides of the transversal, are called alternate exterior angles. When two lines are parallel, alternate exterior angles are equal. So if we're looking at that middle figure again, we can figure out that angle DEY is 60 degrees because it is an alternate exterior angle with angle XBC. Likewise, it is a corresponding angle with angle ABE, and it is a vertical angle with angle BEF. So there were multiple ways to figure out angle DEY was 60 degrees based on what we've done so far. Filling in the rest of the angles, we can see that angle ABX must be 120 degrees because it is supplementary to angle XBC and also angle ABE. We can say the same thing about angle DEB, it must be 120 degrees. Again, we can say it is 120 degrees because it is supplementary to a couple of angles, or we can say that it is a corresponding angle with angle ABX. The other two angles that we have remaining, angle EBC and angle YEF, are also 120 degrees, and we can make any number of claims as to why. In the final figure on the right, we want to find the measure of angle XBZ. So let's take a look at a few ways that we can figure out what that angle is. So if we look at the figure, we know that angle BFG is a right angle because it is marked. That means we can also determine that angle EFB is also 90 degrees because it is a supplementary angle. We also know that angle BEF must be 60 degrees because we're given angle DEB is 120 degrees, and these two angles are also supplementary. And finally, we can figure out the angle of EBF because we have two angles inside the triangle. So we have 90 degrees and 60 degrees, so we know that the angles in a triangle sum up to 180 degrees. So we know that angle EBF is 30 degrees. Knowing that, we can determine that XBZ must also be 30 degrees because it is a vertical angle with angle EBF. Another way to have arrived at that same thing was to realize that angle XBC was a corresponding angle to angle BEF. We could have known that it was then 60 degrees, and knowing that, we could have figured out that ZBX and XBC were complementary angles. So we could have figured out that XBZ was 30 degrees from that. So there were multiple ways to arrive at our final answer, knowing the properties of lines and angles.